Hey guys, this is Mr. Bennett. This is Unit 4. We're talking about electrons, and specifically this is video 4-1. We're going to talk about where to find the electrons in the atom. This is kind of a long video. I'm going to try to talk as fast as I can, but I suggest that if you're getting lost, remember you can pause, you can rewind, you can pause it, take a break, go use the bathroom, stretch, do what you need to do, but make sure that you're doing this slow enough or taking breaks often enough that you can actually listen, take good notes, and make sure that you're understanding what's going on in the video. So take breaks if needed. All right? That said, let's get going. So just as a quick review, what we need to know about electrons from last unit. First of all, we know they have a negative charge. We know that their mass is so small that we basically consider it to be zero. Okay? Outside the nucleus is where we find them. We find them in an area we call the empty space. Starting in this unit, we're actually going to give this empty space a name. It's known as the electron cloud. Okay, so if you look at my picture down here, kind of a classic picture of the atom. Remember, this is a little too big for the nucleus. Nucleus should literally be a tiny little speck, but it contains all of the mass of the atom, and then your electron cloud would be all the way out here to where all the electrons are found moving around. Okay, we'll find out that this shape is probably not entirely accurate, but we are going to name that from now on, the empty space, the electron cloud. Okay, so let's talk about nucleus versus empty space first. Again, a little more review. So the nucleus is a tiny, dense area at the center of the atom. It's basically tucked away nice and deep in the center of the atom. The empty space, on the other hand, or the electron cloud, is where we're going to find the electrons. It's on the surface of the atom, which means that it's easy to access. And it turns out that this idea actually leads to another idea that atoms, basically atoms, it's their electrons that determine how they will react chemically. So in chemistry, when we're talking about chemical reactions, what we're really talking about is how these electrons are interacting. Most chemical reactions, when it comes down to it, it's all about how the electrons are behaving. Okay, so one of the things I noticed last unit was that a lot of you were familiar with the Bohr model. You didn't necessarily know what it was called, but you were familiar with this guy down here, this model. This is kind of a classical model. Scientists came up with it. It is a simple way of understanding how the electrons fit into an atom, but it is not the most accurate way. We're going to start here, but we're going to very quickly forget about the Bohr model and talk about a modern model in just a bit. There is some good things about the Bohr model though. So initially the Bohr model suggested that electrons moved in circular orbits around the nucleus. Nice, clean pathways. And that each orbit was considered an energy level. Okay, this is good, this idea of energy levels. So the idea that electrons can occupy the first energy level, the second energy level, the third energy level, and that the energy levels always have integer values, meaning whole number values. So in other words, first, second, third energy level, etc. There's no 0.5, there's no quarter energy level or anything like that. They're always whole numbers. Okay. Some of you even remembered that the first energy level contains 2, the second energy level contains 8, and the third energy level contains 18 electrons. You didn't know why, because they probably didn't tell you in middle school, but they did tell you the numbers. We're going to learn why these numbers are the way they are, but we'll also find out that this whole idea of circular orbits is actually wrong. Okay? Energy levels are good, but circular orbits are bad. Okay? So let's talk about energy levels and what they really mean. Well, it comes down to the idea that electrons cannot exist between energy levels. In other words, they have to have a certain amount of energy at any given time that corresponds with the energy level that they occupy. So an electron that's hanging out in the first energy level has a certain amount of energy. In order to bump up to another energy level, it's going to have to gain energy, a specific amount of energy, in fact, that we call a quantum. Quantum is really just a fancy way of saying quantity. So in other words, it has to gain a quantity of energy needed, a specific quantity of energy, to bump up to another energy level. Same thing goes if it wants to go down an energy level, it's going to have to give up or lose a quantum of energy to drop back down. Okay? So the further an energy level is from the nucleus, the more energy it takes to occupy that level. And it also turns out that as we go out, these energy levels out here, even though it's not represented in my picture, energy levels 5 and 6 are very, very close. Energy levels 1 and 2 are actually pretty far apart compared to 5 and 6. We'll see a picture later on that will represent this a little better. But the idea is that it takes lots of energy to occupy energy levels further and further out. Okay. Now, we said the Bohr model is bad, and I said there's a modern model that is a better explanation for how electrons behave. The modern model is called the quantum mechanical model. Scary name, but again, remember quantum, just think quantity. Okay, and so what this model really says is that electrons can be considered to behave in a way that depends on the amount of energy that they have at any given time. So what it assumes is that electrons are always in motion, so they're always moving around, they always have some energy, and that they have little, if any, mass. So you really can't determine their exact location. You know roughly where they are, but you never know exactly where they are. Erwin Schrödinger is the guy who came up with this. You don't need to know his name, okay? But just thought I'd mention it. This model that he came up with does not put electrons in orbits. So in other words, those circular orbits, bad, okay? He said they don't move in circles. What it does determine, however, what the model is good at doing, is it tells us the energy an electron can have. So in other words, it will tell us what energy level an electron is at, and it will tell us where an electron can be found 90% of the time. When we say 90% of the time and where it's going to be found, it's a three-dimensional space that we can find the electron in 90% of the time. So let's sum that up. What the quantum mechanical model says is that there's an electron cloud that represents Bohr's orbitals, those circular orbitals. Okay, circle was bad, 3D cloud is good. So there's a 3D cloud that represents those orbitals where the electrons can be found 90% of the time. So these pictures on this page all represent different electron clouds based on the energy level that the electrons are occupying. So here we have a nice simple kind of circular or spherical cloud, really, because it's three-dimensional. It's a sphere. Over here we have some higher energy levels where we start getting other shapes. Okay, the more energy the electron has, we start getting some more shapes. It gets kind of crazy. I think probably the best representation is down here. This would be energy level 1. It's a nice simple sphere. Energy level 2, we keep the sphere, but then we have some other interesting shapes. As the energy level goes up to energy level 3, we get even more shapes. 4 has even more shapes, and so on and so forth. So that the energy level will say, for instance, an electron at an electron at the first energy level will be in this sphere 90% of the time. Second energy level, it will be either in this sphere or these two shapes here 90% of the time. So checkpoint. In other words, for a second, let's think about these questions before we move on. Why are electrons so important? Well, last unit we said that they determine the charge. Okay, we talked about ions. We're going to talk more about ions in the future, but for right now we know electrons determine the charge of the atom. As of today, we know that electrons are part of what explains how an element chemically behaves. Okay, so they describe the chemical behavior of an atom. Okay, in other words, they're the outer part of the atom, and so how they interact with another atom will determine chemical reactions. Okay, why is Bohr's model no longer used? Because it turns out electrons do not or don't follow circular orbits. Okay, instead we found out they follow 3D clouds. So in other words, they can be found in a 3D cloud 90% of the time. Okay, so that's our checkpoint. Again, this is a long set of notes. If you need to take a break, pause it, stretch, get a drink, use the bathroom, do what you gotta do, take some breaks, come back, and complete it. Okay, so hopefully you took a break. If you didn't, take a break. Even just stretch. Okay, hopefully you took a break. We're going to continue talking about the quantum mechanical model. Quantum mechanical model, again, just describes basically how the electrons move based on their energy. So it's all about the energy levels. Energy levels are going to be labeled by what's called a principal quantum number. In other words, it's just an n value. And n, again, is just the number that's associated with the energy level. That's all it is. So in other words, if n equals 1, that means you're at the first energy level, or you're at the energy level that is closest to the nucleus. We talked about this last unit. Remember, electrons like to fill that level first because it's closest to the nucleus, and it turns out that since the nucleus is positive and electrons are negative, they are attracted to it. That's why they're starting there, okay? So electrons always fill that lowest energy level first. I mentioned that there was a graph later on that would better display the energy of each energy level, the difference, that is. So notice here's energy level 1. It has the lowest energy. Energy level 6 up here has pretty high energy. Notice it's a big jump. It takes a lot of energy to get up to energy level 2. It takes a fair amount of energy to get up to level 3, but notice it's less than to get from here to here. Okay, to get from 3 to 4, it's still energy, still costs energy, but it's less than it was to get from 2 to 3. So notice that as we go further and further out, the energy levels are getting closer and closer together. Okay, but they're still going up. Okay, now it turns out that each energy level actually contains sublevels, meaning there are different areas where the electrons can hang out in each energy level. So the quantum number, or basically that n value, the number that we associated with the energy level, tells you the number of sublevels in that energy level. So in other words, if you're in energy level 1, okay, so energy level 1, you have one sublevel. And it turns out that we call that sublevel the S sublevel. If you're in energy level 2, so energy level 2, you have two sublevels, the S and the P. Energy level 3 has 3 sublevels, S, P, and D, and energy level 4 has 4 sublevels, S, P, D, F. Did you notice a pattern? First of all, the number of the energy level tells you how many sublevels you have. Second of all, the order of sublevels are always S, P, D, F. In other words, in energy level 2, we always begin with the S. It doesn't matter whether you're in 2, 3, or 4. S is always the first sublevel. P is always the second sublevel, D is always the third, and F is always the fourth. So if you went to energy level 5, you would have 5 sublevels, right? And they would be S, P, D, F, and then the letter that corresponds to the 5th sublevel that you don't need to know. Okay, so this graph over here kind of does a pretty good job at representing the energy of each energy level, including the sublevels. Notice the first energy level has that one S. Second energy level has an S and a P. Notice that the way we describe the sublevels is we put the energy level in front of it, followed by the letter. So this would be the second energy level, S sublevel. So we call it 2S. Second energy level, P sublevel, we call 2P. Then you have the 3S and the 3P. And then notice here, we have a weird thing that happens. These little levels here overlap. And so the 4S actually has lower energy than the 3D. It's kind of a weird exception to the rule. We'll get more into this in the future. Okay, so we know the sublevels. Now what we need to do is we need to talk about what's happening in each sublevel. It turns out that in each sublevel, there are atomic orbitals. What are the orbitals? Well, think of the orbital as being a specific place that an electron can hang out. Okay, so kind of like Bohr's circles, or the spots where the electrons would fit in the circle. These orbitals are the locations where the electrons can be found. Okay, they're where the electron can be found 90% of the time. Turns out that each orbital can hold 2 electrons. Okay, could hold 1, but maximum occupancy, meaning the maximum number of electrons in an orbital, is 2. Okay, so just like with the sublevels and the energy levels, how there's a pattern here too. The S sublevel only has 1 orbital. Okay, and since each orbital can hold 2 electrons, the S sublevels can only hold 2 electrons. The P sublevel, on the other hand, has 3 orbitals. 3 orbitals at 2 electrons each means it can hold 6 electrons. The D sublevel has 5 orbitals. Remember, it's 2 electrons per, so 5 times 2 is going to give 10 electrons total in the D sublevel. And the F has 7 orbitals at 2 electrons each. That means 7 times 2, or 14 electrons total in the F sublevel. So what's the pattern? First of all, we said the pattern is always S, P, D, F. Okay, for the sublevels. The number of orbitals goes up by counting by odds, meaning you start with 1 and then you go up by odds. So 3, 5, 7. So that means if we had another sublevel here, its number of orbitals would be 9. Okay? And then in order to figure out the number of electrons, you can simply take whatever the number of orbitals are and you can double them. So 1 times 2 would give us 2, 3 times 2 would give us 6, 5 times 2 would give us 10, and 7 times 2 would give us 14. Okay? Alright, so do you need to memorize this? Not necessarily. In fact, you can just remember an easy little equation, and that is n squared. In other words, you take the energy level, whatever it is, whichever one you're talking about, and you simply square it. So if you have energy level 1, you square it, that tells you you have 1 orbital. Energy level 2, you square it, that tells you have 4 orbitals. Energy level 3, you square it, that tells you have 9 orbitals. 4, you square it, that means you have 16 orbitals. Okay? So you simply take the energy level you're talking about and you square it. Alright? That's the number of orbitals that we're getting here. So 1 orbital, 4 orbitals, 9 orbitals, 16 orbitals. Well, how do we figure out the maximum number of electrons? We said on last slide that each orbital can hold 2 electrons. So in other words, 1 times 2 will give us 2 electrons total. 4 times 2 will give us 8 electrons. So these are orbitals. And then this column here would be the number of electrons. So 9 times 2 would give us 18, and 16 times 2 would give us 32. Okay? So if you remember this guy, and then you remember that each orbital can hold 2 electrons, these two things are really easy to do. You don't need to memorize any numbers. Okay? So let's summarize it all up. I know these are long notes. Let's talk about what we need to remember. Remember the energy level, n, whatever the n value is that also tells you the number of sublevels. The sublevel order is S, P, D, F, and each sublevel contains a certain number of orbitals. S contains 1, P contains 3, D contains 5, and F contains 7. So for example, the third energy level, how many sublevels does it have? Well, it's the third energy level, which means n equals 3, so it has 3 sublevels. Okay, what sublevels does it have? Well, the first sublevel is always S, the second one is always P, and the third one is always D. It only has 3 sublevels, so we just go S, P, D. How many total numbers of orbitals? Well, the S has 1 orbital, the P has 3 orbitals, and the D has 5 orbitals. So 1 plus 3 gives us 4, plus 5 will give us 9 total orbitals. I could add it up like that, or I could remember my equation. My equation is n squared. N right now is equal to 3, so that means 3 squared, which would give us, again, 9 orbitals. Notice, same number, and it tells us the number of orbitals. Okay, what's the total number of electrons it can hold? Well, 1 orbital equals 2 electrons. So, since we have 9 orbitals, that's 2 electrons each, means it can hold a total of 18 electrons. Okay, so let's do some practice. Go ahead and pause the video right now. You have the equations already, or the questions already on your notes handout. So pause the video, practice these, and then come back and see if you got it right. Hopefully you pause. Alright, hopefully you pause it. Let's see what we got. So how many sublevels are on the second energy level? That would be 2, because n is equal to 2, so that would be, how many sublevels? 2. What sublevels are present? The first one is always S, the second one is P. So you have S and P sublevels. How many total orbitals are on that level? Well, S contains 1 orbital, P contains 3 orbitals, so 1 plus 3 would give us a combined total of 4. You could add it up like that, or you could just remember that the equation is n squared. N right now is equal to 2, because we're on the second energy level, so 2 squared gives us 4 orbitals. I get the same number either way. I like n squared because it just makes things easier. I don't have to remember this whole 1, 3, 5, 7 thing. Okay, what's the maximum number of electrons the level can hold? Remember, each orbital contains 2 electrons, or can hold up to 2. So if we have 4 orbitals, it's 4 times 2, which gives us a total of 8 electrons possible in the second energy level. Second practice problem says how many sublevels are on the fourth energy level. Okay, how many sublevels? Well, fourth energy level, that means 4 sublevels. What are they? S, P, D, and F. Okay, that's the order. That's as high as we need to know. We don't need to know beyond the 4th energy level. Okay, how many total orbitals are on this level? Our equation is n squared. So that means 4 squared, which gives us 16 orbitals. Okay, what's the maximum number of electrons this level can hold? We take the number of orbitals, 16, multiply it times 2, we get 32 electrons. All right, hopefully you did okay on that. Make sure you fill out the whisk, and then see you Monday.